Hello everyone, I am Meenakshi Chauhan, working as an assistant professor, Kite Group of Institution, Ghaziabad. In this video, I will be discussing about timer and timing diagram. What is a timer? Timer maintains the timing of an operation. The timing is synchronized with some clock. As we have in our normal life, we refer time by using clock. In embedded systems or microprocessor and microcontroller, we have a timer which gives us timing of an operation with the help of some system clock or an external clock. So timer is an important application in embedded systems. We have many purposes to use timer in systems. It can be to measure time generating delays, or timer can be used to count the time interval between events. So timer can be used to synchronize events with some clock. A clock can be a system clock or it can be some externally connected clock. For example, if we talk about a 4-bit timer or counter. So 4-bit timer counts a count up to 2 to the power 4. It means 16. It counts 0 to 15. So 4-bit timer and counter will have a clock input. It will count the clock pulses arriving to it and provides a 4-bit code for counting of clock pulses. So 4-bit combination can count 0 to 15. And these 4-bit count can be decoded using a decoder, and decoder will provide us a timing T0 to T15. So a timer can be based on clock pulses. Now, what is a timing diagram in microprocessor? So as its name suggests, it's a diagram. It is some graphical representation. But here, timing suggests that it's a graphical representation of operation or process in a step with respect to time. So, with the help of timing diagram, we can graphically represent the process or operations in form of steps with respect to time. And this timing diagram will help to understand the process of microprocessor step by step with respect to time. Here, timing diagram gives representation of various control signals. So to execute an instruction, microprocessor generates various control signals, and these control signals can be graphically drawn with the help of timing diagram. So important terms related to timing diagram. Timing diagram represents a generation of control signals in graphical format with respect to time. Some important terms are instruction cycle, machine cycle, and T-state. So what is an instruction cycle? Instruction cycle is defined as the time required to complete the execution of an instruction. Instruction cycle has some phases: instruction fetching, instruction decoding, fetching of operands, instruction execution. It may contain writing of results to memory or output devices. Generally, we talk about the instruction cycle that it consists common phases: instruction fetching, instruction decoding, fetching of operands, and instruction execution. So instruction cycle defines the total time required to complete the execution of an instruction. Now, what is machine cycle. Machine cycle is defined as the time required to complete one operation of accessing memory. It can be memory read or it can be memory write. Input output, input read or output write, or acknowledge an external request. It can be some interrupt request or interrupt request acknowledgement. So machine cycle is defined as the time to complete one operation related to memory input, output, or some external request. Now, what is a T state? T state is the time corresponding to one clock period. Clock is a series of clock pulses. So this one clock period is termed as clock pulse or clock T state. One clock period is termed as T state. So T state is defined as subdivision of the operation performed in one clock period. It represents the work which is done within a clock period. So we can use T state or clock period interchangeably. Now what is instruction format? Instruction format has two important parts. One is opcode and operand. Opcode specifies the operation to be performed, and operand specifies the data on which the operation will be performed. So commonly each instruction has two parts, opcode and operand. And the instruction can be 1 byte instruction, 2 byte instruction, or 3 byte instruction. It means the length of instruction is 1 byte, then it is 1 byte instruction. If the length of instruction is 2 byte, then it is a 2 byte instruction. If the length of instruction is 3 byte, then it is a 3 byte instruction. So for timing diagram, it is important to know the number of bytes in an instruction. As we have discussed that the machine operation can be graphically represented by a timing diagram. So here we are taking an example of a code fetch machine cycle. A code fetch means we are fetching instruction from the memory. So here, as we have discussed that we have T state, and each T state is representing one clock pulse or clock period, and we have already talked about that the processor generates various control signals to execute an instruction. So here we are fetching the opcode from main memory. So here we have a clock or a collection of clock pulses or clock periods. Suppose we have a microprocessor and we have memory. At location 2005, at this location we have an instruction of code 4F. So here we are fetching this opcode from 2005 location. First, the microprocessor will address this location by placing address on address bus. Then microprocessor will tell to the memory that it is a read operation, and the microprocessor will also tell about the opcode fetching operation. The status bits S0 or S1, the combination of these two bits will define the opcode fetching operation. In T1 T state, first the content of program counter will be placed in address bus. Here the location is 2005 in hexadecimal notation. Lower order address will be placed on lower order address buses. These are multiplexed buses. And higher order address will be placed on higher order address buses. So in first T state, the address will be placed on the address buses. So here in timing diagram, in first T1 state, the address will be placed on address bus. So first multiplexed buses will have lower order address, that is 05 in hexadecimal notation. And higher order address bus will have 20 in hexadecimal notation in first T state. So here we are using combination of control signals, so we will represent like this. Once the microprocessor will place the address on multiplexed buses, here AD 0 to AD7, these are the multiplexed buses. These buses can carry address as well as data. When these buses are carrying address and when these buses are carrying data, it will be distinguished by a signal called ALE signal. So microprocessor will make this signal high. It means that the multiplex buses are carrying address. So microprocessor will place the address of location on address buses. It will make ALE active to denote that multiplex buses are carrying address. Once the address has been placed, now IOM bar signal will be made low because this is the memory operation. Memory is being accessed. Here this signal denotes that if it is 1, then this is IO operation. If this control signal has value 0, it means it is a memory operation. So microprocessor will make the signal low to denote that it is accessing memory. Next, status bit S0, S1 will be set to 1, denoting that this operation is opcode fetch operation. So here this IOM bar signal will be made 0 in first T state, and S0 and S1 will be made 1. So here the combination of the control signal will be used. Next, ALE is high, indicating that multiplexed buses carrying lower order address. In T state T2, once the address has been placed on the address buses and corresponding signals has been active, in second T state, read signal is made low by the processor. In T state 2, here the read signal is being made low by the microprocessor, indicating that this is the read operation. Once the multiplex buses has delivered address, now these buses will be used to carry data. So memory will place the machine code or opcode on the data bus. So ALE will be low, indicating that the multiplex buses carrying data. It means the machine code will be placed on data buses, or we can say multiplexed buses. Here read bar signal makes the memory device to load the data on data bus with the content of location addressed by the processor. So memory will load the data on data bus. In clock period T3 or T state T3, the opcode available on the data bus is read by the microprocessor and moved to the instruction register. So now IR register will have instruction or opcode. So in T3 state, this opcode which is uploaded on the data bus by the memory, this opcode will be read by the processor. And in next T4 state, the processor decodes the instruction present in IR register and generates the necessary control signal to execute the instruction. So here the task is unspecified, but it is in the instruction cycle. Then after fetching, the instruction will be decoded. And once the instruction has been decoded, now the decoded instruction will define what are the operation will be performed by the microprocessor. So in this way, we can make or we can draw a timing diagram for any machine cycle. It can be a memory read, it can be a memory write, it can be interrupt request, it can be interrupt request acknowledgement. So here we have collection of T states or clock periods, and in these lines the processor is placing address on the address buses. ALE will be active to denote that multiplex buses are carrying address. ALE will be low to indicate that multiplexed buses will carry the data. IO MVAR signal, if it is 1, then the operation will be IO operation. If it is 0 or low, then the operation will be memory operation. So in this way, we can denote a timing diagram for any machine cycle. Here we have taken opcode fetch machine cycle example. This lecture content was taken from book Microprocessor Architecture, Programming and Application with 8085, written by Sir Ramesh S. Goenka. I have taken content regarding timer from this web link. So in this lecture, we discussed what is a timer. Timer basically is used in embedded system or microprocessor and microcontroller system to generate some timing delays or to count the time interval between different events. We use timers for timing purposes. And timing diagram basically shows some operation of any machine or device with respect to time in step-by-step process. Thank you. Happy learning. Take care.